Let's kick it. Ice, ice, baby. Ice, ice, baby. Alright, stop. Collaborate and listen. Ice.
The Sub-Zero Laboratories. I'm Mr. Frosty.
And I'm Nitro.
And today we're going to talk about the freezing cell protocol, the good science.
And the bad.
When subculturing mammalian cells such as CHO or HeLa, this flowchart provides a simple overview of the protocol in preparation for freezing down cells. Confluence levels will be checked to determine if immediate change should be done or if you should watch with PBS, trypsinize, add fresh media, then count cells. Once subculturing is complete, you can decide whether you want to split or freeze down cells. In freezing cells, preparation for cryopreservation is done by transferring the subcultured cells to a falcon tube and centrifuging at 1800 RPMs for about 10 minutes. The supernatant is discarded and 1 to 2 milliliters of fresh media is added to the resulting pellet of cells. The demonstration of the cryopreservation DMSO use, Mr. Frosty Cryo, and liquid nitrogen storage for freezing will be demonstrated shortly.
So we're going to talk about the cryopreservation of cell lines. Now the aim of cryopreservation is to enable stocks of cells to be stored to prevent the need to have multiple cell lines in the hood at all times.
Cryopreservation helps to reduce the cross-link contamination with other cell lines, microbial contamination, and genetic drifts or morphological changes.
Now the basic principle of successive cryopreservation is a slow freeze and a quick thaw process. Now cells should be cooled at a rate of -1 degree Celsius to -3 degrees Celsius per minute, and they must be quickly thawed in a 37-degree water bath for 3 to 5 minutes.
Cryoprotectant such as the DMSO is commonly used to protect cells from ruptures from the formation of ice crystals. It is commonly used at a 10% final concentration.
The Mr. Frosty Cryo at 1 degree Celsius is a freezing container which is an inexpensive, reusable, and convenient device for storing biological samples like cells at controlled freezing rates at -1 degree Celsius per minute.
Easy to use an anti-mechanical freezer, it is imprinted with graphic instruction. It requires only isopropyl alcohol. Rigid vial holder keeps vial from contacting alcohol. Preventing contamination, vial holder floats to allow thawing in water bath. All components withstand repeated thaw and freeze cycle.
So now we will demonstrate the freezing protocol for you. So here we have the DMSO, dimethyl sulfoxide, which we will create a final volume that is necessary to achieve 10% final concentration that we will add to the already subcultured cells. The DMSO will prevent cell rupture by the formation of ice crystals. Next, we will transfer the cryo vial to Mr. Frosty for use in short-term storage.
The Mr. Frosty Cryo is labeled with easy-to-read instruction including the fill line for IPA and about storage at -8 degrees Celsius for short-term storage.
We will now demonstrate the next part of the freezing protocol. So we prepare the Mr. Frosty and the IPA and place them into the hood. We will now prepare to fill the Mr. Frosty with 250 ml of IPA, by removing the vial holder and then placing the IPA up to the fill mark. This is done in order to place our cryo vial containing the cells with DMSO.
We prepared our Mr. Frosty and we are now at the -8°C freezer, where we will now place it for short-term storage before transferring it for the liquid nitrogen for longer-term storage. This is the dewar, where we place our cryovials taken from the -80°C freezer. The vials here are stored in the vapor phase of liquid nitrogen. The actual liquid phase is filled at around 10 inches at the bottom of the dewar. So this is the dewar. First we're going to take off the lid, put it aside. We are going to get our specialized ruler to measure the volume of liquid nitrogen. Taking it out, as it cools off, you see what the volume is, and since we don't have enough now, we will insert our filler hose into the dewar. After checking the gauge, we will unscrew, turn it all the way on for a quicker fill. You're going to hear a really loud pitch sound, but that's just the vapor phase coming out in high pressure. As the sound goes down, as it stops, the liquid nitrogen will actually fill up the dewar, and then you will turn it all the way off. Take off the hose, and if needed, insert the ruler in and measure it again, see if you got the correct amount, and then just top it off.
Now that the party is jumping.